So we stopped at conversion, type conversion in our last class, right, Mr. Mike? Mr. Mike, where did we stop in our last class? Was it at type conversion? Yeah, I think we did type conversion.
Yes, you're right.
Uh-huh. So now we're going to be moving into working with vectors and metrics, list, and R.
Yes, that. Yes, yes.
Yeah, so R offers different or several data structures to store and manipulate data efficiently. Among the most common are the vectors, your metrics, and your list, right? So these structures are fundamental for data manipulation and analysis in R. So here is an overview of each of them. So what is a vector? A vector in R is the simplest and most commonly used data structure in R. It is one-dimensional array that holds elements of the same data types, whether numeric, character, logical, e.g. right? So now let's create a vector together. So let's know that whenever you are creating a vector only houses data types of what? The same data types of the same what? Numeric of the same data types, right? So it houses elements of the same data type. So if you're talking about data type, we know we did example of data type. We said numeric, integers, character, logical, factor, data, and time, right? So whenever you're using a vector, the one of the structures of the data of the R programming language, you should know that it houses only data type of the same what it houses only element of the same data type. So if I'm to use numeric, if I want to combine informations about a particular thing or a particular object, so if it's numbers I'm using, all of the informations inside that value, inside that vector must be numbers. So if it is character, all the information inside that vector must be character. And if it is logical, all of the information inside that vector must be what? Logical. So the function used to donate or denote a vector is the C, then the paragraph. C meaning combine, right? So wherever you see this C and the paragraph, which is housing the object or element inside, you know that it's a vector. So you can create a vector using the C bracket function, and which C means what? The combine function. So you use a vector to combine data set of what? Or element of the same word data set. So be it logical, character, factor, whichever one that you want to what? Do. So now let's go over to our R and see how we can create a vector together. So I'll come over to REM. So I'll say understanding vector. Understanding vector. So let's create different types so which are character vector, logical vector, element, character, logical, numeric. So now let's create a vector together. So you know that whenever you are creating a vector, you should use the combine function. That's the C combine word function, right? So let's create a character vector together, right? So a character vector means that you are going to be housing every element you are going to be housing inside of that vector must be a character data type, right? So now let's create the character vector together. So before we do that, there are ways you can run codes in R. First one, you can assign them to a variable name which automatically stores what you have the information you have assigned into your environment and the memory of R. Or two, you can decide to write your code without assigning a variable, which just prints the answer without storing them into the memory of R, right? So now let's store let's write a character vector that is being stored into the memory of our, which we are going to be using a variable name to it, right? So we're going to be creating a character vector. I'm going to be naming it CARVEC. That's character vector. And I'm going to be saying, so I'm going to be using my combine function, which is used to what denote a vector, right? So I would say C. Remember, it's always a small letter C, not capital letter C. And my character vector is denoted by, my character data type is denoted by a quote, right? A closing quote, a opening quote, and a closing quote, right? So for each of the text or string that you are going to be using, right? So let's say I want to give it names of girls. I'll just say Ada. Sorry, my quote is open, should open there. Ada. I'll put a comma, so it helps me combine multiple elements of the same data types. Ada, I would say Esther, Vivian, Ada, Esther, Vivian, and what other one can I use? Mm, Amanda. So now when I run this, you see that this has been run, right? So if I say print Chavek, right? So you can see that this is a what, I've already assigned all of this information to what Chavek, and this is making it what, a character vector, because it's now combining more than one characters together. So all of this information, Biada, Esther, Vivian, Amanda, are being stored into the variable name, the character vector. So now let's go into for numeric vectors. I'll just say NUMVC. I'll do 12, 13, 14, 15, 16, and 17. Right? So I'll run. Okay, so you can see that I made mistake with my iPhone. So when I run it, I'm say print number. So you can see that we now have them, right? 12, 13, 14, 15, 16, and what? 17. So these are the numbers of vectors that we have. Sorry, I'm assigning it a W. Right, so you can see that I assigned it to a numeric vector. So we have 12, 13, 14, 15, 16, and 17 being assigned to a numeric be assigned as a numeric vector, and it's being housed under the variable name number vec. So now we'll do the last one, that's the logical vector. So for logical vector, I'm going to be saying logic, then vec. So I'd say false, true, true, false. So when I run this, you can see that it has been saved as a logical vector. So I'll come here and do print. Remember, your print will be in small letter, and I'll say log. So if you want to check whether these elements that you wrote are actually of a logical vector, a character vector, a numeric vector, a factor vector, date and time vector, integer vectors, you just have to use your class function to check the type of data type that you have. So if I do class and I put LOGVEC and I run it, see that it give me a word. Okay, my class is in capital letter, so it will be a small letter. So you can see that it's giving me what, a logical vector, right? So if I still put the same thing here and I say class I do n, you can see that, okay, see, you can see that it's a numeric vector, right? So if I still go back to this Java and do print, you can see that is a what? Oh, I'm not doing class. I'm supposed to use class. You can see that is a character vector, right? If you check here, you can see that is a character vector. So when we do the last one, let me do for integer vectors. I'm going to do TEG vec. Then I'll now do C. Remember your C combined. I'll do 10L, 13L, 15L. Remember, the integer sign, the integer data type is denoted by the suffix L at the ending of your numeric what number, right? So I'll do 16L, probably 17 or 12L, right? So if I run this, that's run. So if I say print intervect, so I'll say, you can see it has printed it. Then if I now say class, let me find the class, that's data type. So I'll come here and find the data type class. So I'll say veg. So you can see that an integer, right? So this is how you can donate what or denote what integers and form vectors, right? Using the data type. So vectors just allows you to assign elements of the same data type into one, right? So if there are elements of different data type, it will not be able to work in a vector, right? So now let's look at accessing a vector. So if you want to access elements of a vector, accessing element of a vector, are we paying attention? Ezekiel and Mr. Mike. Ezekiel.
Yes, yes, I'm following.
Okay.
Yes, I'm following.
Okay.
Yes, I can hear you. I'm following.
Okay, no problem. I can hear you. So now we are going to be talking about how to access.
Can you hear me?
I can hear you clearly. I heard what you said. So we are going to talk about accessing a vector. So let's say we want to access a vector, be it numeric vector, logical vector, character vector, integer vector, date and time vector, factor vector, right? You want to access one of the elements inside the vector, right? So now the vector or this vector uses this one, or R uses the one indexing rule, right? The one indexing based rule, right? Whereas where your first element or your first object is regarded as your one index, like here, your first element here is regarded as 1, index 1. The second element is regarded as index 2. Third element is regarded as index 3. Fourth element is regarded as index 4, and fifth element is regarded as index 5, right? So as the information or as the element goes longer or lengthier, you should know that R starts from the what? The one base index rule, which is your 1, 2, 3. Unlike Python, where your first element starts with 0, it starts with the index position start with 0. So if it is were to be Python, your 10L will be read as 0 index, so 13L will be 1 index, 2 index, then 15 2, 16 3, and 14 what 4. But in R, our first element of a vector is always regarded as the number 1 index. The second element is regarded as number 2 index, number 3 index, number 4, and number 5, right? So now if you want to access element of a vector, regardless of where the element or the position of the vector is, you have to use or the R indexing rule, the one base R indexing rule, which allows you name the first element of each vectors as index one, and what it in sequential order, it progresses like that in sequential order. So now if I want to access the second element or the third, let's say I want to access the third element in the num-vec, right? So now let's say access in the so now to access it, I'm going to put in the name of my, I'm going to write the name of my variable first for that values I want to access. So that will be num-vec, and you're going to be using your square bracket, which allows you access elements in all data structure, right? So I'm going to be using my square bracket, and I'm going to find in which position of the element do I want. So I want to find out what is the exact element or the exact number that is found in the third element. So I want to know the exact value that is in the third element. So because I want to find the third element, I'm going to be writing 3. Right? So if I run this code, it's going to give me 15L as the output, because that is what is actually in the third word. That's actually what is the third value in this word, in this information. Okay, no, it will give me 14 because I'm using the num-vec. So it will give me 14. The third element here would now be 14, right? So if I run it, you'll see that it's giving me 14. Okay, not B, C that is here. So if I run this, you can see that it's giving me 14, right? If I also run that for, so let's say I want to find another one. So say access, let's say we want to access the fifth element. I want to access the fourth element in the char-vec. So access the third element in the char-vec. So I'll say I write the name of my variable name that is housing that information I need to manipulate. So that's char-vec. I would now what write my square bracket, and since I want the third element, I want to see the third element, what's the exact value that where the third element is. I'll now write 3. Then so you can see it's Vivian, right? So if you check on my information where that is being housed under the char-vec, you'll see that my third information is what, Vivian, and you can see it produce Vivian. So if I wanted to make it 4, if I want to check the fourth one, so you can say I have Amanda, right? So now this is how you can house, or this is how you can manipulate or vectors or access vectors of access element of a vector. So whether you are dealing with a numeric vector, you are dealing with an integer vector, you are dealing with a logical vector, you are dealing with the date and time vector, you are dealing with a factor vector, you are dealing with any kind of vector, right? This is the way you can access elements of that vector. So remember that the indexing rule for R is the one base, it is the one base indexing rule, right? So whenever you want to access your first element of the vector is usually your index 1, second element index 2, third element with index 3, unlike Python where your first element is regarded at index 0, second element index 1, and the rest, right? So now we are going to look at accessing multiple elements at the same time. You know this one that we did, we're only able to access just one element, right? So let's say I want to access I want to see the values that are found in index 2 to index 4. So I want it to produce all of the values or all of the elements that are found from index 2 to index 4, so I can see what is in there right now. So I'll now write accessing multiple values, right, in a vectors. So my heading would be accessing multiple values in a vector. So now to access multiple values in a vector, so let's say I want to access multiple values in number vec and vec. So I'll do number and I'll do, so let's say I want to access in for number vec. How many values do we have here? So we have one, two, three, four, five, six, right? So I want to access from the third value to the fifth value, right? So I'd come down to where I've written it, accessing multiple values in a vector at the same time. So I'll say I want to access from number third to the fifth one. Remember to, when you're accessing in multiple value, remember to always put your column at the middle of the value. So this column means that you also want to access all of the information between the 3 and the 5, right? So when you run this, it's going to bring out all of the information between 3 and 5. So when I run this, you'll see, so it has brought out 14, 15, and 16, right? So if I go up and take my number vec, you see that the values from the third one to the fifth one is 14, 15, and 16. If I do the same thing for logical vector, that's the logical vec. So if I do the same thing for the logical vec, so I'll do logic, and I do my square bracket. So let's see how many informations we have in our biological vec. 1, 2, 3, 4, 5. So let's say I want to see from 3 to 5, or let's say I want to do from 1 to 3. I'll do, I want to print out all of the elements from 1 to 3. So you can see it has brought out false, true, true. And if I check it to compare, you see that it is false, true, true. So if I still change it, I want to see the first 4. I can still change it here to 4. And you can see that I brought out the first 4. False, true, true, and false. So if I check and go back there to see whether it matches it, you'd see that it is false, true, true, and what, false. So this is how you can access vector or access element of a what, vectors. Are we getting it? Are you getting it? Do you understand? Mr. Mike and Ezekiel, do you understand?
Yes, but that particular place was, I think it was cracking, we were breaking. So I
Oh,
don't know if you can just recap.
which place? Which
The
place?
last thing you're trying to show us, I couldn't even understand from here. It was breaking. So I don't know if you can just recap.
Okay, so the last, like I said, accessing multiple values of a vector. So you know, in the other one I did, you were able to access just one value, right? So if I want to access the fourth value of a vector, I just write 4. But now if I want to access more than one value of a vector, right? So let's say I want to access from the second value to the third value, or from the fourth value to the fifth value, the same process you are going to make, but the only difference is that now you are going to be putting the first, we are going to be starting with the first number you want to, the first indexing point you want to start from in accessing, and now right, you start from it, you write it there. Then this column indicate that there are different, there are still multiple or more values you still want to access, right? So if I'm saying I want to access from the third value to the fifth value, that's to say that there's still another value in between that I want to access, right? So if I say 3 to 5, it's going to bring out the third number, the fourth number, and the fifth number for me. The same thing with the log bag, right? I want to access multiple
Your,
values of the
your
log
screen,
bag.
your screen is not showing from my end, though.
That means
I don't know if it's open.
it's from your name. Mr. Mike, is it showing?
It's not showing you. It's like there's a network issue because your line is breaking.
Let me stop sharing, presenting, and start presenting again. Can you see my screen now?
Yes, it's clear now. I can see you're sharing now.
Okay, it's okay now. Yeah.
Okay. So now, like I said, accessing multiple values in a vector. So like I said, if you have a vector that has 5 elements, right, or 5 values, and you want to access more than one vector, right, or you want to access more than one element, instead of writing just the position of one, you could as well say I want to access to values between index 3 and index 5. So if I say you want to access values between index 3 and index 5, that means it's going to be producing you about 3 values, right? So it's going to be producing you the value that is in index 3, the value that is in index 4, and the value that is in index 5. So if I go to my number vec and I say, look at what I said, accessing multiple vector here, and I want to access 3 to 5, right? If I go to my number vec, what this is going to be printing out for me is the third, from the third value to the fifth value. So from the third value to the fifth value is 14, 15, and 16. And if you check here on my result, you see that it's accessing the same thing, 14, 15, and 16. If I want to still perform access multiple value on my logical vector, and I want to access just from 1 to 4, so if I check my logical vector, if I start from 1 to 4, it is going to be true, false, true, true, and false, right? So if you check here, you'd see that what both of them what that gave the correct answer. Are we good to go?
Yes.
Okay.
Yes, yes, yeah.
Okay. So now we'll move over to the next one. So you can see here, you can access individual element of a vector using indexing. How uses the one based indexing, meaning the first element is accessed with index 1. So every first element of the vector, be it numeric, be it integer, be it whatever, the first element there is always regarded as 1, index 1, second element index 2, and you go through that index when you want to access any of the what indexing what any of the values in that indexing what position, right? So now let's say this is they've shown you how to access it here. So you have seen how to access values, right? This is accessing one output and this is accessing multiple output, right? So now let's say we want to perform a numeric operation, like a mathematical operation using the vector that we have created. You can perform mathematical operation using vector that you have created or worked on directly. So if I want to add 1 to all of the numeric values that I've created, the numeric vector I've created, I just need to write the name of the variable and just put +1 in front of it and it adds it up. If I want to do the same thing, multiply by 2, it's also going to add it up. So now let's go and see how we can perform mathematical operation on a vector. So I'll come down here. Performing mathematical performing mathematical operation on a vector. So now I have I'll check my character vector, right? I think I have only one vector because when you're performing numeric calculation, you only do numeric calculation on numeric what element or numeric value, right? So now my number vec has a numeric value, so I'm going to be adding, or I'm going to be multiplying, doing some addition or some multiplication what to the vector I have created, and that will be most specifically on what the number vec, because I think that's the one that has a numeric what that has numeric numbers on it now. So let's say I want to add perform numeric vector. So I'll start by adding, right? So when I want to add, I'm going to be using the name of my variable to add. So I'll just say number vec plus maybe 2. I want to add 2. When I run it, you see that it has been added, right? So if I compare it, the numbers together, right? So I'll go back and see what I've run. Okay, let me just keep my value here. So my number vec says 12, 13, 14, 15, 16, and 17. Now I created a mathematical formula that will add 2 to each of the numbers. So if I say 12 plus 2 will give me 14, you can see it here. 13 plus 2 will give me 15. 14 plus 2 16, 15 plus 2 17, 18 plus 16 plus 2 18, and 17 plus 2 is what? 19. You can see how how we have operated or performed mathematical operation on what? On our vector, right? So we can also perform different kind of mathematical operation, from addition to division to product and the rest. So if I decide to add number vec times 10, right now I'm performing multiplication what? On my vector, my numeric vector. I'll say enter. You can see that it has multiplied 12 by 10, giving me 120. It has multiplied 13 by 10, giving me 130, and so on and so on, right? Forth. If I decide to divide it, number vec divided by 2, you can see the answer that it is giving: 6.0, 6.5, 7.0, 7.5, 8.0, and what? 8.5. So if I decide to raise to the power, press raise to the power, so I would say number vec. So now this one is going to multiply. This one will allow me to multiply each of the value by itself, right? So if it is 14, it's going to be saying 14 times 14. If it is 15, it's going to say 15 times 15. If it is 16, it's going to be saying 16 times 16. If it's 17, 17 times 17, as the case may be. So if I run this, okay, there's no C in front. So you can see it, right? So it ran 14 times 14, 15 times or so, Abby. Okay, 12 times 12, 13 times 13, 14 times 14, 15 times 15, 16 times 16, and 17 times what? 17. So this is how you perform mathematical calculation on our numeric vector. Do we get that? Do we get that? Are we following? If you are following, just leave a thumbs up. Ezekiel, Mr. Mike, Tolutope, are you all following? Okay, Mr. Mike already left a thumbs up. So now we'll be moving over to metrics. So metrics in R, a matrix is a two.
So the line is breaking. We hardly could hear you. It's just breaking.
You could hardly. Where did you not hear me from? Hello. Hello.
Just hello, hello. I said we barely could hear you. The thing is breaking. So I just want you to take note of that. But we are fine now.
Okay. But you understand the mathematical calculation I just performed?
Yes. Apart from the last one, please, I want to ask the last one that multiplied the number by itself twice.
Yes.
Was it double star
Yes, double star.
that you use? I mean,
Yes,
double star.
double
Okay.
star. Yes, double star. So now we'll be going on to metrics. So unlike your vector, which is a one-dimensional array, that means it can either come in form of a row or come in form of a column for your vector, but it cannot come as a row and a column. So get it, a vector can only come in form of can come in form of a row, a row, right? But when you talk about two-dimensional array, two-dimensional array means that number has a role, it consists of a role and consists of a what? A column, right? So now a matrix is a two-dimensional arrays, and each element must be of the same word data type. So when I'm using a matrix, each of the elements must be of what? The same word data type, right? So matrices are useful when working with mathematical operations and data that has rows and column. So for those who did mathematics, maybe further maths, and in our thesis in school, you would know that maybe you might have come across metrics and how you can manually calculate them, or how you can manually use your codes in R to calculate them, and so forth, and so on and so forth, right? So now here I will be teaching you how to create a matrix, right? So now let's move on to creating metrics in R. You can create matrix elements using the index, the matrix, right? So you can, when you want to create a matrix in R, you need to use the metric function called the matrix, right? And what follows in are now called the argument, right? So after using your metric function, whether you want to assign it to a variable or you just want to run it like that, it's left for you. If you want to assign it to a variable, that means you want to maybe reference to that particular matrix in the future, or run or manipulate the matrix in the future. But in the case where you don't want to assign it to a vector, right, that means you just want to run it and get your answer without it being stored in the memory of what, R. So now let's see how you can create a matrix together in R. So okay, so I'll go here. So when you want to create a matrix in R, there are things you need to consider or put in mind. Number one is the data length. Number two is the range of values that you want to use, right? Let me just write it down. Things to consider when things to consider when performing a matrix. Number one, the data length. Comma, yes, the data length, the data range. So let's create a matrix that has a data length of 10. So when I mean data length, I mean each of the individual number, the count of each of the individual numbers. So if I say I want a data length of 10, probably I want from 1 to 10, or I want from 11 to 20, or I want from 21 to 30. So any range of data I want and the data length I need should be what you should consider before running or performing metrics on your R, right? So if I say I want a data length of 10, okay, I'll say use a data length of 10 using of 10 and data range from 11 to 20, create a matrix. So now we are going to say creating a matrix. I don't want to assign my matrix to any variable name, so I just want to run it and show you people, right? Because I'm not going to, I'm not going to be using it in the future, or when I'm maybe explaining, or I can decide to also still assign it to a variable name and do what, and use it to maybe perform manipulations in this same analysis, especially when I want to access it now. So now let me assign a variable name to my matrix. So if I want to assign a variable name to my matrix, I might just use D3 or D2, which means dimensional array 2, or which means dimensional array, right? So I'll just do D dimensional array 2. So that's what I'm giving my matrix. So I would say matrix So this is my matrix by function. Now I said I want to use a data length of 10 and a data what range of what 20. So have it in mind that since I've stated what I want to use, my data range is 10 and my range should be 11 to 20. So my range can be 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So data range includes, so if I say a data length of 10, you can see that this 11 to 20 has met up our criteria. We say we want the data range to be 11 to 20, right? So my data length, let's count if it's up to 10 or more than 10. So I'd say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see that this data length is 10. If I decide to add 21, I am now breaking the rule, which is what not is more than what 10. So now let us write our metrics together, our metrics function. So now since I want 11 to 10, I can either write it in two places, in two forms. I can write it as a sequence, or I can write it as a vector, right? So if I'm writing it as a sequence, that means I'm going to be writing 11 column 20, comma, then followed by my n rows. So remember that when you want to assign your n rows, let me give a space, or your n column. So now when you want to assign your n rows or your n columns the number that should fit, you should make sure that the two values you are going to be putting there are the multiple of your data length. So if I'm going to be putting any value in this row and putting any value in this column, I would ensure that these two values, if I multiply them, will be the multiple of this 10 here. So what can give us 10? You can see that it is 5 and 2 now. So I have to put 5 either in row and 2 in column, or 2 either in row and what 5 in what column, right? So now I'll now put, since 5 times 2 is a multiple of 10, I can try to say, okay, I need 5 rows and 2 columns. Then I'll run. Right, so you see that it has run, right? So if I say print DA2, so you can see what it has printed out for us, right? So it has given us it has fulfilled our criteria, the data length of 10 and what a data range of 11 to 20. So when you are creating a matrix, you should have these two things in mind of what you want to create, and you should ensure that your NR and your C column are the multiples of your what your data range. Hope we get it. Hope we all get it. Hope we all get the what I'm saying.
Yeah.
Okay, so move on. So by row or by column, you can specify whether the metric should be filled by row or by column. Column is by default anyways. So now let's assess element of a matrix. To access element of a matrix, you know that since you are now involving rows and column, you are going to be assessing them you are going to be assessing them both by your rows and your column. But the method of assessing still remains the same thing, but what only changes are the values inside what the square bracket now. So let's go and perform assess our values inside of a what of a matrix. So I'll go there. So assessing elements So now the name of my matrix is DA2. I write DA2. Then so I'll put my square bracket. right? So now, what element do I want to access? What the difference between this one and the vector is that vector is a one-dimensional array, and thus you just be imputing one value inside of a vector. But in this situation whereby we have a two-dimensional array, we are going to be working with both the row and the column. But in vector, we are working with only rows because a row is a what? Horizontal what? Line, right? So in vector, in matrix that makes up of two-dimensional array, a row and a column, we are going to be putting one value for the row and one value for the column depending on what we want to what extract, right? So now let's say I want to extract row number 1 in column number 2. So now this, look at what this will give me. So you see that it's giving me 16, right? So what it just did is that if it first went to row number 1 and was not specific on which column should I remove, or do I want to remove this figure. So I want row number 1, but I want to be specific in what? Column 2. So if you trace row number 1, you know that the value inside column 2 is what? 16. So I could still do that. Let's say I want to access value of a matrix, just one value of a matrix. I'll still say DA2 square bracket. Let's say I want to access row number 4 and column number 2, or okay, let me say row number 4 and column number 1, right? You see what it's going to give us now. You can see it's giving us 14, because if you check, our row number 4 is what? 1, 2, 3, 4, and column number 1 is what? 1. So the value that fell into row number 4 and column number 1 is what? 14. And you can see that it's giving us 14 here, right? So now let's say you want to access multiple values at the same time, not like you're accessing just one in this place. So I'll say accessing multiple elements of a vector. So accessing element of a matrix, same thing as we did for vector, but the only difference now is that we're making use of our row and we're making use of our column. So if I say that my square bracket, so my first value I'm going to be writing is my row before the comma that is now housing my column, right? So I want to access multiple values of a row. So I want to access from 3 to 5, right? I'll say from 3 column 5. That's for my row. Then for my column, how many rows do I want? How many columns do I want to access? Let's say I want to access the 2 columns that are there. That's 1 and 2. I'll say 1:2. So you see what it's going to give us. That if you trace down to row number 3 and 5. So let's move down to row number 3 and 5. So row number 3 to 5, you can see that it is 3, 4, and 5, right? So everything in row 3, everything in row 4, and everything in row 5. So if I say 1 to 2, this is my column 2, column 1, and column 2. So what it does is that I'm now going to go to row 3, go and look for what value is in column 1 and column 2. Now the value in column 1 and column 2 is 13 and 18. You go to row 4, go and look for the value that is in 1 and 2. The value in 1 and 2 is 14 and 19. It now goes to row 5, goes to look for the value in column 1 and 2. Yes?
Looks like this network is really showing us today. We are struggling to see the screen and it's
Okay.
just
Can
breaking
we
kind
reschedule
of.
for tomorrow so I don't waste my effort thinking I'm teaching and you guys are not understanding? Maybe the network could be better. You know the rain, the weather here, the rain is not good. The weather is not good. Rain has been falling. Can you hear me?